I'm Keno Ramirez, BSCE 23. For fulfillment in our subject, Basic Electrical Engineering, I'm going to discuss about superload. So after we have learned in nodal analysis, this kind of problem here in superload, there is a volt source. So for solving the equation easily, so we have the circuit here, which is given. So for me, I prefer to redraw the circuit so that it will be easily for me to answer it. So here, I count the number of nodes, node 1, node 2, and node 3. Then after that, we're going to find the voltage reference. For easy to solve the problem, we're going to have our voltage reference, the one with the number or the more number of elements. So that is on node 1. So after I redrawn the circuit, so this is the circuit. So we're going, for me, I use voltage polarity in solving this thing. So I put polarity plus, minus, plus, minus, plus, minus. So in Ohm's law, we know that if a current enters a positive polarity, so that is positive. So for easy solving also, let's assign the current for those who are entering the positive. And here, so this is all our voltage reference, which is equivalent to 0, or our ground. So I'll name this I1, I3, and I2. So I think we can erase this now. So after we have redrawn it, we're going to solve this. So this is our superload. So let's solve the equation using KCL, or Kirchhoff's current law, at supernode. This is our supernode. So in Kirchhoff's current law, that law states that those who are entering the current or entering the those who are entering the node are positive, and those who are leaving the node are negative. So 4 is entering node 3, supernode, leaving I1, leaving I2, entering I2, leaving I3, and entering 9 volts, equals to 0. That is our equation 1. So let's reduce the equation. So 4 plus 9 minus I1 minus I3 is equals to 0. So I1 plus I3 is equals to 13. So we have our equation 1 to solving the circuit. So next, we have our equation 1, I1 plus I3 is equals to 13. Equation 1. So we have two unknowns. Solving two unknowns, we need two equations. So we have our V1 and V2. Using Ohm's law, V1 is equals to I1 R1. Our R1 is 2. 1/2. So I1 is equals to 2 V1. So our I1 is equals to 2 V1. And our V3 is equals to I3 R3. So our I3 here is here. So we have, I think this is V2. So R here is 1/6 ohm. So our I3 is 6 V2. So substituting these values here, so we have 2 V1, 6 V2. So we can erase this thing. So in finding the another equation, because we have two unknowns, so we need two equations to solve the two unknowns. So we can find an equation there in our supernode, which V1 minus V2 is equals to 5 volts. Potential difference. So this is our equation 2. So solving this, we can multiply this equation by 2, negative 2. So we have 2 V1 plus 2 V2 minus 10 plus 2 V1 plus 6 V2 is equals to 13. 8 V2 equals to 3. So V2 is 3/8. If it is 3 over 8, from the first equation, so V1 minus 3 over 8 equals to 5. So V1 is equals to 3 over 8 plus 5. So we have V1 is equals to 43 over 8 volts. So that is our answer in the equation.